Okay, today we will talk about the probability distribution second part, and it's also about the continuous probability distribution. So, different from the previous introduction about the probability distribution, we just talk about yes or no. Okay, today we will to talk about when the context is about its continuous random variables. That means it could be any value in an interval or on a real line or in a collection of intervals because it's a continuous condition. So it's impossible for us to talk about the probability of the random variable assuming in a particular value because there are so many values we can talk about because it's a continuous context. So instead, from such parts, especially for the continuous probability distribution, we will talk about the probability of the random variable and assuming it is a value within a given interval. Okay, given is a value given within an interval. So there are three main types of the continuous probability distribution. The first one is a uniform one. Okay, it looks like a square. Okay, and the area of it is the probability for the events, okay, happen within such interval. And the second one is a normal probability distribution, and it looks like a bear shape. Okay, and this probability distribution is also the most used one. Okay, in our daily life. And the third one is the exponential probability distribution. It's a little bit similar like to the Poisson probability we talked about last week. Okay, but there are still some different, and we will talk about later. Okay, so the first one we will introduce is a uniform probability distribution. Okay, and it's a random variables that is uniformly distributed. So that means if in such condition you will set an interval for the events or the issues that could be happen, and if such events or issues they are out of the interval, okay, then the probability of the density function will be 0. Okay, but if it happen within an interval, for example, the x happen between the a and b, okay, we will say the probability density function will be 1 divided by the width of such interval. That is, we use b minus a, okay, and it would be the probability density function. So here you will find the a will be the smallest value and the b will be the largest value we can consume. So usually the probability is the proportional to the interval's length, and it would be multiplied by the uniform probability density function. Okay, so the second one is the expected value. It usually will be we use the smallest value and the large value, and we add them together divided by 2 is the expected value. And the variance of it, we will use it by the difference between the interval with the square and divided by the 12. Okay? So let's use an example to introduce it. It's a Salater's buffet. Okay, they found customers are usually charged for the amount of salad they take. So the sampling suggests that the amount of the salad they taken is uniformly distributed between 5 ounces and 50 ounces. So here you will find the salad weight is from an interval between 5 and 50 ounces. And the density function for the f of x, okay, you will say, yes, follow the formula we learned here, okay, for the if the ounces happen between 5 and 50, okay, you will find it could be right like 1 divided by the difference of the interval. But if it happened out of the such interval or elsewhere, we could say its probability density function will be 0. So here you will find if we use 50 minus 5, you will get the interval difference is 10. Okay, so here if the x is located between the 5 and 50 ounces, its function of the density function will be the 0.1. But if it elsewhere, that means out of such interval, it would be 0. Okay? And the area in the gray area means the probability of the weight between 5 and 50 ounces. So if you would like to know the probability for it, you still need to calculate it. You cannot just write down the uniform probability density function, okay? So what is the probability that a customer will take between 12 and 50 ounces of the salad here? The first you write down here is, you know, the interval will be from 5 ounces to 50 ounces. And the density function here is, you know, is the difference between the interval and divided by 1, so it's 0.1 here. So the probability between 12 and 50 is in such a dark gray area, okay? So we will use the width of the interval and multiply by the density function here. Okay, so it would be the width of the interval is 3, okay, because it's from 12 to 50, and the density function will be 0.1. So we multiply it together, then we'll get the probability for the customer to take between 12 and 50 ounces of salad is 0.3, okay? So if you would like to know the expected value of the x here, okay, we can still to calculate it, followed by the expected value formula in the uniform probability distribution is use the small value plus the large value and divided by 2. Okay, so here you will know the small value is 5 and the large value is 50. So we divided them, it would be by 2. Okay, add them together and divide it by 2. So the result for the expected value is 10. And the variance of the x here, you will find, follow our formula, is the difference between the interval and square it, then divide it by the 12. So you will get the result is 8.33.